Hi, my name is Esme Wilson, and this is my Game Engine Fundamentals module, also known as Ci517. This is my semester 2 assignment of creating a game engine subsystem. I opted for a physics subsystem, and I've implemented it into a ECS. So I'm going to fire up the game, and I'm going to show you what it's about. So it's a simple sorting game, and you want to put the color which associates with the section, and you want to just push them by walking into them, and they will adopt the player's velocity and momentum and so forth. So here we just pushed the pink one into the wrong section, so it gave us out a prompt, which is the Easter egg to say that that is in the wrong area. And there was another one for the green square. And if we do it again, we'll get another one. There's another one. And then there won't be one for this. There is an output for velocity because there was a bug that was on this square for debugging, but I have not removed that output just yet. But yeah, it's very simple sorting game. The player has free mobility. If they walk through the platform, it will just jump them straight up to the top. They can go around and hit things, but the objects will not leave the level, as this is colliding, and yeah. I'm going to walk through the code now. So I have here the components. I've created components up here. So I've added a world physics component, which will apply gravity, drag, and prevent sliding. Sliding was when the drag was chopping the velocity of an object down, but it was never setting it to 0. So it would slide across very slowly, infinitely, for no particular reason. So I added this prevent sliding function to stop that from happening. And yeah, so this is just like world resistance is what I've put the variable as. It's a public variable, so a user could change it by just calling on it and setting it to something else. I set it to 0.1 by default because that is my preferred gravity for this game. And along with that, I've also added a rigid body component, which has a function called transfer velocity, which will, depending on the mass of the two objects that are colliding together, the force which will act on the stationary object is completely relative to the stationary object and how heavy the colliding object is. So if the colliding object was lighter than the stationary object, they would not take 100% of the force that goes over, because it wouldn't be, because of the nature of how the physics work in this game. If the force is 2 on the smaller cube and it's 2 on the bigger cube, they're going to appear to move at the same speed because it's not relative to their mass. So they have mass, and the mass is set in the physics component in the constructor. There's an overloaded constructor here, which we will set mass, speed, bounciness on the x axes and bounciness on the y axes. And this is also called in my game. And we'll just have an example of this is all the entities which are in use in this game. And I will just show you that. So where is the one with the physics? So here, this one here has physics. It has a mass of 6, a speed of 1, a bounciness on the x value of 100, and a bounciness on the y value of 50. For example, just to showcase the bounciness, I'm going to take away the background, which is the color of the background, which makes you not be able to see the square when they're in there. So I'll just show you this. So if I hit it's going to bounce And that's what that bounciness does. Let's see how it kind of goes at the straight thing. So if I was to change the bounciness of these squares to a lesser number, they should not adopt the full force of the full force. See how they kind of like don't get to reach the other wall. They lose their momentum as they hit. That can kind of indicate when an object's more like a steel ball rather than a tennis ball. Like there's no elasticity in the object that's retaining the force, I think. What else do we have here? We also have collision, which is simple A, B, collision. We've got colliders. I've got a correct overlap function, which I've written. That will simply, if it's a correct overlap Y and correct overlap X. So if the correct overlap Y is like for the ground, so it will put the entity back onto the ground's X plus ground's Y plus the height of the object that should be sitting on the ground, because of the SDL has 0, 0 at the top left. And then for the X, it's kind of a similar way, where if you want to spawn them on the left of the object, I've put transform X, and then you want to spawn it like from that X, but like minus the width of the object. And then if it's spawning on the right of the object, if the object could be wider, so you want to do it with the collider width rather than the object's width rather than the rigid body's width, for example, because the rigid body could be narrower than a wall, but if you were to set it to the rigid body's width, it would put it into the middle of the wall, which was a problem I had, and that's why it's like this. So yeah, let's look at the game CPP. This is how it's laid out. So all of the objects which are created here using a manager, the components are all attached in the constructed function, and the handle key events will add velocity to 1, which would keep, because then we also multiply the force. So if we go to physics, we can see that every frame the transform X is plus equal velocity, which is their vector 2D values, and that times by calculate force, which is the force equals mass times speed. So if the velocity equals 0, then they're not going to have any force. So this means by setting velocity to 1, it stays true to the natural force of the object. We also have a calculate speed, which is a reversed version of that function for if we needed to find it for a rigid body, for example, which doesn't have a set speed. The bounciness, this is how to reverse the force by the percentage of the bounciness, because like how I set the bounciness from 100 to 50, that means you transfer 50% of the bounciness over. So if you were to hit the if you were to hit the wall at 100, say like the velocity hitting the wall was 5, if it was a 50% bounciness, you would come back off the wall at only 2.5 velocity. So there is that matter of drop off considered. It's not the most elegant and well thought out way, but it's something that I developed myself, and I think it's important to just include that. So my game, we'll go through this again. We've got setting the velocities. In the update function we have, this is where it will tell if the square is on the wrong side. I've got it set up on positions because I didn't want the Easter egg to be kind of spamming the output. I just for the sake of not just happening in the background. So it's just once it passes a specific y value, if it's on the left or the right side, just say it once, and then that's it. And then we've got this just makes sure that the player is like staying on the screen. So if it goes off the screen on the left, come back on the right. Here we've got the sorry, I just gotta read. Oh, this spawns back. This doesn't matter now. This is actually outdated code, but it was used to, if the object goes off the screen somehow, it will spawn back in at the center. And then we've got the AAB. So this is all collision. And so collision. We've got where the collision is pretty much all the same. Like uses the same structure, which is why I said in my report that I think this could definitely be condensed down into individual functions rather than repeating the same code over and over. So that is something I would look to implement if I spend more time on this beyond the submission. So, and it is something I'm interested in doing, so I will definitely be working on this to try and improve my skills for next year. Left wall collision, rigid body and left wall collision, player and ground collision, rigid body 2 and platform. This is actually platform. That's the wrong name for it. But yeah, I will just show how I've shown how I can change the bounciness, but I'm just going to say how I can change the weight of the player square, for example. So I'll show you how it moves if this is the weight at 1.1, and I'll show you if I move it to 1.6, for example. It's very much, oh, sorry, that might not have been a big enough jump to show the difference, but if I was to set it to 3, it should work. Yeah, so it is very much faster, which maybe is not very realistic, but I think it's because it's got a set speed and it is heavier. So if it's heavier at the same speed, it could be that it just moves faster. But yeah, this is something that would have to get sorted in terms of refining it and making it more accurate to real life physics. But my focus on this was to prioritize the rigid body and collision. I would also like to add that the rigid bodies don't collide with each other, but I do want them to be able to collide with each other. But yeah, that is pretty much the entire game and how it was constructed.